Hello, and welcome back to another video. Today we will attempt to solve a problem from the 1961 International Maths Olympiad. So exactly the kind of problems you would solve on a rainy afternoon. Well, actually, do we really need bad weather to do some math? What's going on there? Well, anyway, let me know in the comments what you think about that. And yeah, the problem is cosine to the nth of x minus sine to the nth of x is equal to 1, where n is a natural number. Let's dive in. So first of all, let's look at the range. So we know that the range of sine of x is from -1 to 1 inclusive, and of course analogously also the range of cosine of x is from -1 to 1 inclusive, and then of course from there it follows that the range of sine to the nth is of course also between -1 and 1 inclusive, and also cosine to the nth, because of course if you take something that's between -1 and 1 to the nth power, then this of course stays between -1 and 1. Now let's look at the case where n is even. Yeah? So when n is even, then of course it follows that the range of sine to the nth and cosine to the nth is reduced to 0 to 1 inclusive. Because of course if you multiply something negative with something negative, then this of course becomes positive. Now we can make a key observation. Let's consider the case where cosine to the nth is smaller than 1. If that is the case, there are actually no solutions to this equation. Why? That's the case because sine to the nth, the range of sine to the nth is always greater or equal to 0. So if we have this cosine to the nth is smaller than 1, then we would of course need sine to the nth to be less than 0 in order for this left side to add up to 1. And that's why there are no solutions to the equation if cosine to the nth is smaller than 1. Now let's consider the other case, so where cosine to the nth is equal to 1. So then we have, of course, this is if and only if cosine of x is equal to 1 or -1. And this is the case if sine, of course, is equal to 0. And this is if and only if sine to the nth is equal to 0. So this is of course the case if and only if x is a multiple of pi. Because, for example, we know that the zeros of the sine function are at the multiples of pi. So in conclusion we can say if x is a multiple of pi, then our equation here is solved, because then cosine to the nth is equal to 1 and sine to the nth is 0. So we can write this down. If n is even, then the set of solutions is given by, and here we have a set that includes all the multiples of pi. So we write k times pi, where k is a whole number. Next, we can consider the case where n is odd. Here we have no restrictions to our range, but we can still make a similar or two similar observations as we did here in the even case, where we argued that there are no solutions to the equation when cosine to the nth is smaller than 1. And here in the odd case, similarly, we can say if cosine to the nth is smaller than 0, so if this here is smaller than 0, then there are no solutions, because then sine to the nth would have to be smaller than -1. But of course, that would be out of the range. And yeah, analogously also if sine to the nth is greater than 0, then there are no solutions, because then cosine to the nth would have to be greater than 1 in order for this left side to add up to 1. Let us first look at the case where n is equal to 1. So we simply have cosine of x minus sine of x is equal to 1. Now if we square both sides, then we have cosine of x minus sine of x all squared is equal to 1 squared, which is of course 1. And now the second binomial formula gives us that this is equal or equivalent to cosine squared of x minus 2 times sine of x times cosine of x plus sine squared of x is equal to 1. Now, of course, it should be common knowledge that cosine squared of x plus sine squared of x is equal to 1 for all x. And if that's the case, then of course this term here in the middle, so minus 2 times sine of x times cosine of x must equal to 0. So in other words, sine of x times cosine of x must equal 0. And this is of course the case if and only if sine of x is 0 or cosine of x is 0. So let's make a little more room for this calculation. So the first case, if sine of x is equal to 0, then of course if this equation here should be satisfied, then cosine of x must be 1 at the same time. And this is the case if and only if x is an even multiple of pi, so 2 times k times pi, where k is a whole number. And the second case works analogously, so if cosine of x is 0, so if here this is 0, then of course sine of x must be equal to negative 1. So, and if cosine of x is 0 and sine of x is negative 1 at the same time, then x must be an odd multiple of pi that is divided by 2. So for example, 3 halves times pi, 5 halves times pi, 7 over 2 times pi, and so on and so forth. And if you want to write this as a set, you can do it like this. Yeah, you have here the even multiples of pi, and you just subtract pi over 2. Next, let's look at the case where n is odd and greater or equal to 3. Yeah, so for n greater or equal to 3, we have that the absolute value of cosine to the nth of x is definitely smaller or equal to cosine squared of x, and similarly sine to the nth of x and the absolute value of that is definitely smaller or equal to sine squared of x. Yeah, because of course n is greater or equal than 3. Now if that's the case, then this gives us an inequality, namely that cosine to the nth of x minus sine to the nth of x is definitely smaller or equal to cosine squared of x plus sine squared of x, which, as we have already mentioned, is equal to 1. Now, equality holds only then when cosine to the nth is equal to cosine squared, of course, and negative sine to the nth is equal to sine squared. So we can follow that this must hold. Now, let's look at the first case. So cosine to the nth of x is equal to cosine squared of x. Well, that is if and only if cosine to the nth of x is equal to 0 or cosine to the nth is equal to 1. And yeah, similarly in the second case, if negative sine to the nth is equal to sine squared, this is the case if and only if sine to the nth is equal to negative 1 or sine to the nth is equal to 0. And if cosine to the nth is equal to 0 now, so we consider this case, then of course sine to the nth must be equal to negative 1, so that this equation here is satisfied. And this is if and only if cosine of x is 0 and sine of x is negative 1. And this case we already had here in the n is equal to 1 case, so we just copy here the set from above. And the second case, so cosine to the nth is equal to 1, then of course sine to the nth must be equal to 0. And this is if and only if cosine of x is equal to 1, sine of x is equal to 0. And this is also something we already had for the case n is equal to 1. So we can also copy that set. So to conclude, we can write all the solution sets down for an overview. So when n was even, then the solution set was just all the multiples of pi. Then if n was odd, then it was a union of these two sets right here. Yeah, so the even multiples of pi and then negative pi over 2 plus 2 times k times pi, where k was a whole number. And if we now want the solution for any n in the natural numbers, then of course this is just the intersection of these two sets. And this is then of course the even multiples of pi. Yeah, this sums up this video. I hope you enjoyed it. It would mean a lot to me if you would leave a like and subscribe. This will also keep me motivated to make more content and similar videos like this in the future. As I then know that there is actually an audience who is interested in these kinds of videos. Please also comment with feedback and recommendations for future videos. And other than that, see you hopefully very soon, and take care. If you like this content, please leave a like and subscribe to this channel for more videos in the future. If you would like to support this channel financially, there's a donation link in the description.